Hi, seventh grade. We're starting a new unit today on scale factor. We're going to spend probably the next 5 school days on this unit. If you have a ruler, please bring that for tomorrow's lesson. I know about half of you said that you had one. So there are 3 goals I'd like you to pause this video and copy down in your notes. Goal number 1, be able to recognize a scale enlargement and a scale reduction. That goal should be pretty easy, and that will be explained a little later. Goals 2 and 3 are related. They're just opposite of each other. So we're going to be using multiplication to find new dimensions of shapes after a scale factor is applied. And goal number 3, use multiplication to find the scale factor when given the new dimensions. So we're going to be able to find either the new dimensions or to find what's called a scale factor. So on to the notes. So what is a scale factor? So the math definition is in 2 similar geometric figures, the ratio of their corresponding sides. When do we use scale factor? So scale factor is used when we want to make say a picture either much bigger or much smaller. For example, if you are designing a bedroom in a house and if you draw everything that you want to be in the bedroom, you are not going to draw a life-size picture of a bedroom because that would be far too big. So you need to scale that way, way, way down so it can fit on a piece of paper. But you want the room to be proportional so you can tell what shape the room is and how big everything will be. Another example would be if I want a swimming pool in my yard and I tell the designer or the architect that I really want a swimming pool that's shaped like an L. So I might say, well, I really want it to look like this. Not like that. Oh, something like that. It's like, oh, that is the shape I really want my pool. So what I could do is, instead of drawing a life-size pool, I could draw a scale factor picture. And I could say, well, I want this to be 25 feet long this way. This will be 4 feet. And let's say this is 15 feet. You get the general idea. I'm not drawing a life-size pool. So I could say that, oh, this is a scale factor of, let's say, 1/50th, because this picture is 1/50th of the size of the real pool. The other example, like if you are in science and you are studying and like a cell and you want to like imagine what the cell looks like, we have to make that picture much bigger in order to study it. So that scale factor would be bigger, or that would be an enlargement. I know this can be a little confusing right now, but when we move on to examples, it will make more sense. So, quick recap, scale factor is the ratio of the corresponding sides. So if we have a shape, we can enlarge it and make it bigger, or we can reduce it and make it smaller. But we want to keep the shape proportional. So if our rectangle, if the side of the length is 3 times bigger than the width, so 3 inches and 1 inch, if we had a scale factor of 2, So if we multiply this by 2, we would multiply the 3 inches and the 1 inches by 2. And we would look at, this isn't measured correctly, but we would have something like 6 inches and 2 inches. So that way it stays proportional. So it stays proportional. All right, moving on to the examples. Labels are very, very important. So an example would say a rectangle has a length of 5 inches and a width of 3 inches. What are the new dimensions if the rectangle is multiplied by a scale factor of 3? So we are studying this rectangle, but we need it to be a little bit bigger. Maybe it's going to go on a poster or something. So we are going to multiply the length and the width of the rectangle by 3. So all we have to do is take the length, take the width, and we're going to multiply both of those by 3. So the length was 5 inches, multiply by 3, we get 15 inches. The width was 3 inches, multiply by 3, and we have 9 inches. So when we draw our new rectangle with those dimensions, it will be 3 times bigger than the original. And the scale factor of 3 means that everything will be 3 times bigger. And this, of course, is an enlargement because it is getting larger. Notice that labels are very important. All right, a swimming pool. A swimming pool has a length of 150 feet and a width of 50 feet. An artist draws a picture of the pool with a scale factor of 1/100th. What are the dimensions of the drawing? Is this a reduction or an enlargement? So this is a huge swimming pool, and of course the artist isn't going to draw a rectangle that is 150 feet long. So he is shrinking it by a size of 1/100th. So what we would need to do is we have length and we have width, and we are going to multiply 150 feet times 1/100, and that would equal 150 over 100, which would be 3 over 2, or 1.5 feet. So the length of the artist drawing would now be 1.5 feet, and the width would be 50 feet times 1/100, which would equal 50 over 100, which equals half a foot. So the dimensions of the artist drawing, the length would be 1.5 feet, and the width would be half a foot. And of course, that is much smaller, so that would be a reduction. Okay, question 3. A window has dimensions of 3 feet by 6 inches. What would the dimensions be if a scale factor of 1/9 was applied? So we have 3 feet, we have 6 inches, and this sort of problem does give you some options. If you prefer not to deal with 3 feet, you could say that 3 feet is equal to 36 inches. That is an option you have. You don't need to do that. We are going to not do that for this problem. but either way we'll come up with the same answer. So the scale factor is 1/9. So we're going to be multiplying both of these by 1/9. That ends up as 3/9, or 1/3 of a foot. And 6 inches times 1/9 equals 6/9, or 2/3 of an inch. And if we wanted to keep the labels the same, we could understand that 1/3 of a foot is equal to 4 inches, but either answer is fine. This, of course, because we multiply by a fraction, is a reduction. Our picture is smaller. Okay, a circle has a diameter of 6 inches, so that would look something like this if that's a perfect circle. The diameter would be 6 inches. So that's the distance across the circle through the middle. What is the diameter of the circle in feet if a scale factor of 6 is applied? So scale factor of 6 means we want the diameter to be 6 times bigger. So we would do 6 inches times 6, which would give us 36 inches. However, we want the diameter in feet, so we can divide by 12 because there's 12 inches in 1 foot, and that would be 3 feet. Is this a reduction or an enlargement? Well, our circle is getting bigger, so we have an enlargement. Question 5. Now we are figuring out the scale factor when given new dimensions. Number 5 says, a rectangle started with a length of 3 inches and a width of 4 inches. So I'm going to start with L and W. We have 3 inches and 4 inches. And it goes to 12 inches and 16 inches. So we're trying to figure out, well, we know that this is an enlargement because it says the scale factor of an enlargement. And the jump from 3 inches to 12 inches should be equal in proportion 4 inches to 16 inches. In both cases, hopefully we can figure out that we multiplied by 4. Because 3 inches times 4 is equal to 12 inches, and 4 inches to 16, or 4 inches times 4 is equal to 16 inches. Last example, a triangle starts with a height of 1 foot. So let's say we have 1 foot, and a base of 8 inches. I am not actually measuring these, I'm just drawing. What is the scale factor of the reduction if the new height is 2 inches and the new base is 4/3 inches? So this is a reduction. We have 2 inches. We have 4/3 of an inch. And really, when you are trying to find the scale factor, you only need to focus on one of the pairs of numbers because they will end up the same. So we're going to focus on 1 foot and 2 inches. We're going to convert 1 foot to 12 inches to make our life a little easier. And I can see that 12 inches is 6 times bigger than 2 inches. And because I am shrinking or reducing the shape, I can say the scale factor is 1/6, because my new shape is 1/6 of the size of the original shape. So those are your examples on scale factor. I apologize that especially the beginning of the video was a little confusing, but I'm hopeful that after you have seen these examples, this will make sense. Please remember to bring a ruler tomorrow if you have one. Thank you.